Yes. Hi, hello everyone. तो कैसे हैं आप लोग? I hope so all of you are doing well. So, welcome to another session of the master series of class 9, class 10th. So, today we are going to look into the next exercise जो है NCERT में, which is trigonometry. And I hope so all of you are doing well. Am I audible? Yes. So, if you are someone who is not aware about के series exactly क्या है and what do we do is, we have this master series for class 9th and 10th जहाँ पे हम NCERT के हर chapter को cover कर रहे हैं. And not only that, with every chapter we are first of all going to understand what all concepts do we have, and then we will go through the exercise that we have in NCERT. So for class 9, it's every Monday at 7 p.m. and that for class 10, it is every Friday at 7 p.m. Like right now, I'm live. So this series is very helpful for those who want to just improve in general. अगर आपको मैथ्स को स्ट्रॉन्ग करना है, let it be 9th and 10th. And 9th and 10th की मैथ्स ही आती है in your GAT exam and IMB UG exam as well, right? So if you want to check out the previous set of sessions जो हो चुके हैं, so around 17 to 18 sessions हो चुके हैं. So I would suggest you to check out the Career Launcher CVT का channel जहाँ पे separate playlist होगा for class 9th and 10th. So you can check them separately. And these sessions are hardly 25 to 30 minutes. So it's not like कि काफी वक्त ज़ाया होगा आपका. So you can definitely go through all of them and complete your NCERT का series as well. Now, let us look into what are the major definitions or formulas that we are going to make use of. If you guys have watched the previous two sessions जो trigonometry पे ही थे, so ये तो generally clear होगा आपका. But let us still have a look through them. We need to remember the 6 trigonometric ratios that we have and the fact कि ये table भी use हो सकता है. But आज का session is majorly based on proving कि मुझे LHS को prove करना है as some RHS. So what is it exactly? So let's focus on exercise 8.3 of NCERT. The very first question is asking us कि we need to express that the trigonometric ratios sine, sec and tan in terms of cot. Okay. So first of all, let us understand कि what is the relationship between tan and cot. So cot is what? 1 by tan of A. So I can similarly say the other way around कि tan AB 1 by cot A हो जाएगा. So it means I have expressed tan A in terms of cot. Now the next thing is secant into cot. How can we do that? So we will make use of the identity that we know 1 plus tan square A is equal to secant square A, and now I can just plug in the value कि tan क्या है? 1 by cot, and this will be 1 by cot square, and hence secant square A is equal to this expression. But हम यहाँ पे रुकेंगे नहीं. Let us just simplify this further, that secant square A is equal to, if I'm taking the LCM over to the other side, so this is what your expression should look like. Cot square A plus 1 divided by cot square A. And if I'm removing the square, so you should be getting plus minus of under root of the same expression that we have just written above. तो हमने तो express कर दिया secant को, right? Now the next thing is, how do I express sine A? Now what is the second or the third formula is 1 plus cot square A is equal to cosec square A, and now what I can do is I can substitute the fact कि cosec क्या होता है? 1 by sine. So this is what? 1 by sine square A, and this is in turn equal to 1 plus cot square A. So it means my sine square A will become, if I'm going to swap or basically take the reciprocal, so this will be 1 by 1 plus cot square A. And yeah, we are done. So if I want to remove this square as well, so we will get plus minus of under root 1 plus cot square A. So I hope so this conversion is understood. And ये indirectly आ सकता है क्वेश्चन में that if the value of cot is given for instance, तो मैं sin की वैल्यू कैसे निकालूं, secant की वैल्यू कैसे निकालूं या tan की वैल्यू कैसे निकालूं. So in those questions, this conversion is required, and you can make use of it to calculate the value of sin A or secant A. Now let's move on to the next question. The next one is choose the correct option, and we need to also justify कि हमने ये option क्यों choose किया है. So the first expression or the question is 9 secant square A minus 9 tan square A. So first of all, let's take whatever is common. तो हमने 9 common ले लिया. And now we can make use of this identity that I know as a matter of fact कि 1 plus tan square A is equal to secant square A. So it means what will be my tan? Tan हो जाएगा secant square A minus 1, and this is what I'm going to substitute in this expression itself. So secant square A minus secant square A minus 1. Now we are just going to open up the bracket and simplify this. And if you will see, secant square A is getting cancelled, thus we are getting 9 as the answer. So option B is correct. In justification में यही formulas हम कह सकते हैं that with the help of these formulas, I am getting a particular answer, which is option B. So I hope so this question is clear to all of you. Now let's move on to the next one. 1 plus tan theta plus secant theta multiplied by 1 plus cot minus cosec. So what we can do is, what if I am breaking my tan as sine by cos and my secant as 1 by cos, and the other one, which is cot, can be broken down as cos by sine and 1 by sine. Now the next thing is to take LCM. In the first case, we can take cos theta as the LCM. So what we are getting is cos theta plus sine theta plus 1. So we are done with this bracket. Now moving on to the next one, we have sine theta, which is sine theta plus cos theta minus 1. Now if you will observe, I can apply one formula, which is a plus b, a minus b, which is what? A square minus b square. अब आप ये सोच रहे होगे कि कौन से दो वैल्यूज है, what should I assume a and b as is? A is basically cos theta plus sine theta. So this is your a and your b will be 1. So it means after applying the formula, what is it? A square minus b square divided by sine theta and cos theta. Now I can just open the bracket जो यहाँ पे है. A plus b whole square, what is it? A square plus b square plus 2ab. So same हम यहाँ पे apply करने जा रहे हैं. So what is it? Cos square theta plus sine square theta plus 2 sine theta cos theta. We also have minus 1 here. In the denominator we have sine theta cos theta. Now if you guys remember, sine square theta plus cos square theta तो 1 होता है, and this one will get cancelled with the minus 1 जो यहाँ पे है. And what are we left with? 2 sine theta cos theta. तो ये sine theta cos theta भी cancel हो जाएगा, and what you are left with is only 2. So as per this calculation, your correct answer is option number C. And let me know in the comment section if you guys are also getting the same as the answer. If yes, very good. Now let's move on to the next question. We need to evaluate the value of the expression secant A plus tan A multiplied by 1 minus sin A. Now in these type of questions, the best way is to break your given expression into the simplest form, as in secant is 1 by cos and tan is sin A by cos A multiplied by 1 minus sin A. Now in this case, in the first bracket specifically, हम देख सकते हैं that cos A is the LCM. So let's take that. So in this bracket, what we are having is 1 plus sin A divided by cos A and 1 minus sin A. So if you will see these two brackets specifically, again I can apply A plus B, A minus B ka formula on a similar line. So in the numerator, I'll get A square minus B square. In the denominator, I am having cos of A. So what is this? Now 1 minus sine square A is basically cos square A divided by cos of A. I can cancel one of the cos, and the answer is cos of A. So how many of you are getting the same as the answer? Just confirm. Okay. So it means as per the options, option D is correct. right? Now the next question, evaluate the value of the expression 1 plus tan square a divided by 1 plus cot square a. So the numerator is what? Secant square a, and the denominator is cosec square a. Now if I want to consider secant क्या होता है? 1 by cos, and cosec क्या होता है? 1 by sin. So it means indirectly I can write it into this way. Sin square a divided by cos square a, or tan square a is the answer, which is option D. Right? And we are done with this question as well. Now the next questions are based on proving the following identities where the angles are acute and the expressions are well defined. So let us focus on the left hand side. If you will focus on the left hand side, let us simplify this as cosec is 1 by sin theta minus cos theta divided by sin theta. Now 1 minus cos theta, we also have a square. So 1 minus cos theta ka whole square and divided by sin square theta. Now can I say I can substitute 1 minus cos square theta instead of sin square theta, and then I can again apply the same thing. A square minus b square को हम कैसे लिख सकते हैं? A plus b, a minus b. So that is what I'm going to substitute here, which is a plus b and a minus b. So it means one of the factors I can cancel it out, and if you will see, this is what your right hand side talking about. So this is equal to RHS. Is this clear to all of you? And we are done with the proving portion. Now let's look into the next one. Question number 4. Again, we have an expression in the left hand side and we need to prove it equal to the right hand side. So let's focus on the left hand side. Let us take LCM and see क्या आता है. Cos A multiplied by 1 plus sin A, and what we are getting is cos square A plus 1 plus sin A ka whole square, and this is equal to what? Cos square A plus A square plus B square plus 2AB, right? And in the denominator we are having cos A multiplied by 1 plus sin A. Now I can make use of these two parts in the given expression, that sin square A plus cos square A is equal to, if I'm adding both of these, the result is 1. 1 plus 1 is 2. So 2 plus 2 sin A divided by cos A multiplied by 1 plus sin A. I am taking 2 common here. So this is your 1 plus sin A divided by cos A, and again 1 plus sin A. I can cancel these two parts, and 1 by cos A is secant. So what you are having is 2 of secant A, and thus your RHS is proved. So I hope so the steps are clear and there is no confusion as such. Now looking into the next part. Question number 4, and this is very important because हम इसमें कुछ identities use करने जा रहे हैं which will help you to solve this question. Now I'll start off with the left hand side again, and we are going to prove that this is equal to the right hand side. How can I write tan? Sin theta by cos theta, right? And cos as cot as cos by sin. This plus cot is what? Cos by sin divided by 1 minus sin theta divided by cos theta. Now let us take LCM and देखते हैं कि क्या expression आएगा. Sin by cos divided by sin theta minus cos theta divided by sin theta, and plus cos theta divided by sin theta and cos theta minus sin theta divided by cos theta. So this is what your expression is looking like, and as a matter of fact इसमें क्या है कि denominator का denominator numerator में चले जाता है, and the same is true for all your functions. So sin into sin will become sin square theta divided by cos theta multiplied by sin theta minus cos theta, and again denominator ka denominator will go into the numerator, so cos into cos will become cos square and sin theta multiplied by cos theta minus sin theta. Now in this expression if you will see, sin theta minus cos theta हम common ले सकते हैं, but इस expression में it's उल्टा है. My cos is coming first and then sine. So let us take negative common, ताकि ये sign जो negative बन जाएगा because I'm taking negative common. And now I can eventually take sin theta minus cos theta as common. And now what we are having is sin square theta divided by cos theta minus cos square theta divided by sin theta. And now we can take LCM in this particular bracket and हम solve करते हैं. So we were having sin theta minus cos theta. And in this bracket, if I'm taking LCM, cross multiplying each other, the LCM is sin theta cos theta. So LCM is sin theta cos theta. In numerator, if you will see, it will be sin cube theta minus cos cube theta. Now one formula that you must remember is a cube minus b cube क्या है? A minus b, a square plus b square plus ab. So इसी को हम use करने जा रहे हैं in the numerator. Okay? So it means I can write this down as a minus b, which is sin theta minus cos theta multiplied by a square plus b square. So it means if my a is sin theta and my cos theta is b, sin square theta plus cos square theta to 1 hota hai. So I'm just putting a 1 here directly, plus sin theta cos theta divided by sin theta cos theta. So I can cancel out sin theta minus cos theta here, and what we are having is I'm going to split my numerator with respect to the denominator as 1 divided by sin theta cos theta plus sin theta cos theta divided by sin theta cos theta is 1. So this is what? 1 by sin is cosec and 1 by cos is sec plus 1, and we are done with the proof. Okay? So this is the proof for this question. Now the next one, prove that your LHS is equal to the RHS. Now every time remember that जब भी under root आता है, one of the trick is to rationalize and see whether you can get the right hand side or not. So for instance, if I am having under root of 1 plus sin A and under root of 1 minus sin A, I can rationalize this as how? 1 plus sin A. Right? And if you will see, numerator में जो factor है, it is repeating twice. So I can rewrite this as 1 plus sin A whole square. And under root में A plus B, A minus B का formula, which is A square minus B square. So it means this square and under root will be cancelled. And what I'm left with is 1 plus sin A divided by under root में तो cos square A आ गया. And if I'm removing it out of the under root, you will get cos of A. And 1 by cos is what? Again, I'm going to split my numerator with respect to denominator. So it is sec A plus tan A. And we are done with the question. Okay? So I hope so there is no confusion in this part as well. Now the next one. We need to prove that your left hand side is equal to the right hand side. So consider your left hand side and take sin theta and cos theta common in the numerator and denominator respectively. So if I'm taking sin theta common in the numerator, it is 1 minus of sin square theta divided by, if I'm taking cos theta as common, it is 2 cos square theta minus 1. Right? And if you guys remember, हमारे पास एक identity होती है cos 2 theta की, that it is 2 cos square theta minus 1 or 1 minus 2 sin square theta. एक और identity होती है which is cos square theta minus sin square theta. All the three are equal to your cos 2 theta. So it means 1 minus 2 sin square ho या 2 cos square minus 1 ho, both of them basically imply that it is cos 2 theta. So from this expression, I can cancel off cos 2 theta, and what you're left with is sin by cos, or it is in turn tan of theta. Right? So it means this is equal to the right hand side. Now this is the next question. Again, starting off with the left hand side, for instance, I can apply the formula of a square plus b square plus 2a and b. plus cos square a plus secant square a plus 2 cos a secant a. Now just make a pair of these two. Sin square a plus cos square a क्या होता है? 1, right? And ये जो दो फैक्ट वो वैल्यूज है, sin a cos a, both of them will get cancelled and the result is 1. And for cos and secant a is also the result is 1. And what is that one identity that I can make use of in the case of cosec square and secant? Now just remember 1 plus tan square a क्या होता है? Secant square a, and 1 plus cot square a क्या होता है? Cosec square a. So I can substitute these two equations in the given cosec square and secant square and write our final answers. So this will become 1 plus ये जो दो हैं ये हमारे पास बन जाएगा 2 plus 2, and over here I am going to substitute cosec square क्या हो जाएगा 1 plus cot square a, and secant square a क्या हो जाएगा 1 plus tan square a. Now combining all the constant, if you will see 1 2 3 4 5 6 7, so 7 plus cot square a plus tan square a, and you are done with the proof, which is equal to the right hand side. Now this is the next question. Prove that the given expression is equal to the right hand side. So let's solve this separately as mentioned in the question. So left hand side क्या है? 1 by sin a minus sin a and 1 by cos a minus cos a. So if I am taking the LCM, ये क्या आ जाएगा 1 minus sin square a divided by sin a and 1 minus cos square a divided by cos a. So this is equal to cos square a divided by sin a multiplied by sin square a divided by cos a. So let us cancel out all the similarities जो हम देख सकते हैं. Sin a into cos a is my answer. Now let us solve your right hand side also separately, and then हम चेक करेंगे कि उसमें भी क्या यही रिजल्ट आ रहा है या नहीं. So how can I write my tan as sin a divided by cos a plus cot को कैसे लिख सकते हैं? Cos a divided by sin a. Now if I am going to take the LCM, what you are going to get is sin square a plus cos square a, and जो डिनोमिनेटर का डिनोमिनेटर को न्यूमरेटर में आ जाएगा, which is sin a into cos a. Now this denominator is already equal to 1, and if you will see, this is equal to the left hand side. So left hand side is equal to the right hand side, hence these two expressions are basically equal to each other. Now this question, we need to prove that these two brackets are equal to each other, and not only that, both of them are equal to tan square a. So let's focus on the first one. The first one is 1 plus tan square a is secant square a divided by 1 plus cot square a is cosec square a. So it means definitely this is tan square a. We have done a similar question on the basis of this, जिसमें हमें tan square a मिल रहा था. Now moving on this, 1 minus sin by cos and divided by 1 minus cos by sin. So ये bracket है हमारे पास. So we have cos a minus sin a divided by cos a, and further divided by sin a minus cos a divided by sin a. So this is the whole square. Now if you will see, in the numerator we are having cos a minus sin a, and the same is over there, but sin का difference है, so I am taking negative common. And negative common लूंगी eventually because you are squaring it, so उससे कोई फर्क नहीं पड़ने वाला. So it means these two will get cancelled. Sin a divided by cos a का whole square will give you tan का whole square. Okay, so this question is also done. So that is it for today in this session, and we have completed exercise 8.3 of NCERT in trigonometry. In the next session, we are going to start off with the applications of trigonometry, and if you guys have any doubts or queries, please write them down in the chat section. And thank you so much, everyone. Feel free to subscribe and share it with your friends.